Welcome back. Nice to see everyone again. In case you've been monitoring Canvas, I posted your grades for assignments 1 and 2 for those of you who submitted stories. And then if you haven't submitted one or both stories, or if you'd like to update your submissions, then you can do that at any point throughout the course. You all did well on these assignments, so I wouldn't recommend resubmitting, but if you wanted to, you could. But I want you to take risks, and that includes potentially telling a bad story every so often. So to help you do that, taking risks isn't going to kill your grade and doesn't even have to affect your grade in the course. But it can really boost your storytelling skills if you are willing to try it. So, food for thought. For this next module of the course, module 3, we're going to take a little bit of a detour to get everyone up to speed with programming in Python and managing files and code in GitHub, and also using a tool called Jupyter Notebooks to organize projects. And depending on how this course and the rest of the classes this week progress, we might cover all of module 3 this week, or we might spread it out over the next 2 weeks. So we'll see how things go. If you're brand new to programming, then it's, as I mentioned on Friday, this is going to be a relatively steep learning curve. And then if you're an experienced programmer, then I think you're probably going to find this module somewhat slow. But I hope you'll still get something out of it. So on Friday, I had asked whether any of you had programmed before, and a bunch of you raised your hands. But who's programmed specifically in Python? Wow, all of you have. Just a little bit.
Just a little.
Okay, so okay, that's cool. And then how about any data science-y stuff, like programming, like analyses or data visualizations? Has anyone done that?
Right now with one of my classes, we're using R for network analysis.
Cool. Okay, so I had planned for today to go through kind of programming basics, but it seems like you might all already have that. So let's see, are any of you, would you consider yourselves advanced programmers or mid to advanced? No. Okay.
I don't know about anybody else. I just took CS1, so I've used
CS1.
Python a little bit, but not extensively.
Yeah, it's I'm familiar with it, but I definitely forgot a lot since 19 spring or whatever it was 2 years ago. Okay, well, so we have a few options. So what I plan to go through is if statements and loops and operators and variables and stuff like that. I think I don't know, do you all remember that stuff? Okay. So that doesn't seem like a good use of time. Since I knew some of you had programming experience, although now it seems like all of you do, my other ideas were that as an intermediate level of programming experience, so it sounds like maybe we might all be there, we could try writing an English to Pig Latin translator, just to do a little demo coding. And then I also had some ideas for, if you want a kind of extra challenge. But maybe we'll start with the Pig Latin translator and then we'll go from there. Okay, does that sound good? We'll get some practice. So I know some people who aren't able to join synchronously do not have programming experience. So this is going to be interesting. But I guess if you're watching this asynchronously, then maybe reach out and we'll touch base during office hours. And then there's the module 1 or module 3 material to but it sounds like it might need to be a little bit more self-directed. Okay. Okay. So have any of you used Google Collaboratory before? Okay. Well, okay, let me share my screen here. Okay. Okay. Here's Collaboratory. So I can paste in this link. Where is my chat window? Let's see. There it is. Zoom likes to put all the windows right on top of each other. So cool. Okay. So the what this lets you do is has anyone used Jupyter notebooks before? No. Okay, let me show you how this works. So all the code here is going to run on Google's servers. So there's no like setup. You just need to go to a web browser. To access Collaboratory, you need a Google account. So if you don't have one, you'll need to sign up for one. And then you can use this environment just like a Jupyter notebook, although if you haven't used Jupyter notebooks, then that is meaningless. So the way it works is you kind of have two types of, so a notebook is organized into these cells, and cells can either have text, and you can format the text using Markdown, which is like a little formatting language, and then you can click on click on different formatting things to if you don't want to memorize the syntax. Okay. And then if you're familiar with like LaTeX, you can, is anyone familiar with LaTeX? No, for equations? No. Like you can like type formulas and it'll, you can just put them right in. So it's pretty nice. You can also paste in graphics and that sort of thing. A code cell. Oh, so to like format the to be able to type, you double click the cell, and then and then it shows a little preview on the right, and then to run the formatting, you hold Shift and press Enter. And then the second type of cell is a code cell, and there you can just define Python code and run Python code. So you could say x equals 10, and then it runs it, and then just like normal Python. Or you could define functions. and then we could say like, etc. Does that make sense? And to run a code cell, you press Shift and Enter. Okay. Okay. And then let's see. Well, okay, well, okay, I'll just skip to so that's collaboratory. So we're gonna write code in collaboratory. The second tool we'll use is GitHub, and you've been accessing GitHub, to see the outline of course materials so far, but we're gonna use it to manage code for like basically from here on in the course. So you'll use this to submit assignments and stuff like that. So the module 3 material will get you like kind of up to speed with the basics of GitHub. And so I'd recommend checking that out. If you started to go through the module 3 material already and like, are confused by anything, then we'll leave time in class on Wednesday to ask questions about how to get set up with all these accounts. But this is the second tool we'll be using most. And then if you have any questions, Slack is like a great place to ask questions as you're like, I'm basically on Slack all the time. So, minutes before an assignment is due, that's a good place to ask, because I get crazy amounts of email, but on Slack, it's like a manageable flow of information. And so good place to ask questions. Okay. Okay. So let's see. So let's see, Pig Latin. What are the rules of Pig Latin? Okay. So let's just dig into it, and yeah, we'll see how this goes. So the rules of Pig Latin, is everyone familiar with Pig Latin? Okay. So formally, the rules are, if a word begins in a consonant, then all the letters before the initial value are placed at the end of the word sequence, and then you add AY. So like pig becomes igpay, Latin becomes atinlay, and then okay, so that's one thing. And then if you have like consonant clusters, so multiple consonants in a row, like smile, then you just like move them all in a block to the end. So smile becomes ilsmay. And then if a word starts with a vowel, then the consonant block is effectively like has a length of 0. And so that length of 0 block gets moved to the end, so nothing happens, and then you just add AY. So eat becomes, oh, and I guess you add, well, we can make it up, whether if it's if there's no consonants at the beginning, you can either add yay at the end, like eat yay, or you can just add AY. I guess there are dialects of Pig Latin that we could choose between. Okay, does that make sense? So yeah, so let's maybe let's start by defining a function that works with one string. So we'll take in a single string like hello, and then what should come out of this function is the Pig Latin translation of that word. Okay. So yeah, Nathan.
I was just wondering, what does eng2pig stand for?
Well, I'm just making up this function, but it's going to translate like English to Pig Latin.
Okay, I see. Thanks.
Yeah, so how would I start? So I have to know like consonants and vowels. So yeah, what do you think? How would you start this off? Yeah, Nathan.
Maybe like an if statement, like if it's a, a vowel, then like, or maybe a loop that like finds like when, like that like finds exactly like that keeps going until it runs into a vowel, and then
Okay.
like when you find the value, then it's like if it's um or I don't know, I don't really know. Something like that.
Okay, yeah, so some kind of loop. Yeah, Kiara, did you want to,
Yeah,
did you have a,
I was just gonna say maybe we could start out making a list that would be like vowels equals all of them and consonants equals all of them, and then you like when you're trying to identify, you could just say like if it's in vowels or consonants.
yeah, that sounds useful. So it's like, uh, okay, something like that. Okay. Yeah, and then what could we do with this?
I have a
Oh, yeah.
question. So is that how you make a list in Python with like a single quote or something like that?
No, yeah, so let's dig this out of a function. Yeah, so vowels is a string. Oh. If I wanted a list, does anyone know how I could convert that to a list?
You do like a square bracket and put commas in.
Yeah, I could do that, or I could just say like list
Oh yeah, I thought you meant
vowels,
when
right?
writing it. Sorry.
Oh yeah,
Hmm.
yeah, but yeah. So if I typed this in, like I could have defined vowels in this way also. But then we could do interesting things like, so I could say like A in list values. So A is a vowel, but B is not. But then the same thing, it also works for strings. So like A in vowels and B is not. But then it's case sensitive. So A is not in vowels. And then like B is in, B is, uppercase, right, that's also case sensitive. B, lowercase b is in consonants. Okay. So now we have a little way of determining whether a particular character is a vowel or not. There's some weirdness like AE is going to be in the list. Oh, just kidding. It's not going to be in a list of vowels. It is going to be in the string vowels because AE appears next to each other. And so that's kind of a weirdness. So we're going to have to be careful there. But, food for thought. Okay. Does anyone know about, okay, so Nathan, you mentioned loops. So that seems useful. So let's say we have a string, hello. Then how could we loop through the letters in X? How can we do that?
Like add one each time, but like, is it like a while loop? Is that like what it's called?
We could use a while loop. So we could say like, okay, let's have some index. And then while I is less than length of X, then we could print the ith element and then increment I by 1. Okay. So that'll loop through the string. how else could we do it? Is that what you're thinking, Nathan? Or
Yeah, or like I guess a for loop.
how would that work? Or Isha, did you have an idea about?
Yeah, I was just gonna say like a for loop, like for something in the, what did you call it?
X.
An X, yeah. And that'll just go through everything in X.
Yeah, that'll work too. Okay. So this is a little more compact. Also, while loops are just in general somewhat dangerous because like if I had neglected that line, it would just run forever until the internet crashed because it's running on Google servers. So I don't know, we don't want that to happen. I mean, we might, but not today, not during this demo. Okay. Okay, so it wouldn't actually crash all of Google. There are safeguards, but okay. Okay, so now we have a way of getting through the list. How could we check if the particular letter is a consonant or a vowel?
Sorry, I was just gonna say you could do an if statement. I think you were saying the same thing.
Yeah, so how would that go?
So it would be like if C in list consonants, I guess. Then if you want to like append it to the end or remove it, I forget exactly the words. But
yeah, so we don't even need to make it a list. We can just it can just be because we know that from this loop that C is going to be a single character if X is a string. Okay, so if C is in consonants, then yeah, maybe we want some kind of like prefix string. And then, yeah, how could we append C to the prefix? How could we do that? Amelia, I know well, I don't know if I'm correctly reading your expression, but I'm seeing like a confused vibes or maybe.
I'm just
But do you have any questions?
I'm just like going back into the archives of my brain and just trying to think. Well, I remember there being something where you could, because this is like the reverse of appending something, because it's bringing it to the front, right?
Well, what if I did this? Like, so X is hello, right? What if I want to make X, and what if I had like?
Oh yeah, you do just want to append it to the end, but then you also want to delete it, like for H, like you'd want to bring it to the end of the word, but like remove it from the beginning.
What if I wanted to make? Yeah, I think you have the right check. What if I wanted to make like a string hello, comma, space, world, exclamation point? Could I do that from just X1
Yeah.
and X2?
Yeah, you would just append X2 to X1.
Is it just like with the plus operator?
Yeah, you could just do this, right? And do you know about the like in place operator, like plus equals? Remember that? So if I did like, if C is in consonants, then I could do like prefix plus equals C. So that'll start off, prefix starts off as empty. And then when it gets to consonants, we're going to just put that on whatever the end of C is. So this is equivalent to prefix equals prefix plus C.
Why would you do that instead of saying prefix equals C?
Because like maybe if we're adding the AY at the end, then we could do the plus equals, but I also haven't in a while, so I'm forgetting.
Yeah, that's a great question. So if we have something like smile, then the first letter is going to be a consonant, and then the prefix is going to be S. And then the second letter we want the prefix now to be SM.
Mhm.
But if we just replace prefix with C, then it would just be M. So we'd have kind of overwritten the S with the new consonant.
Oh, okay.
Okay.
So then once you run into a vowel, are you just going to take like the rest of it and put that at the front of the prefix? Like, is there, I'm forgetting if there's like, I assume there's a function that just puts it right at the front.
Yeah, well, let's try to make it. Yeah.
Or can you just put everything else into like a different variable and then add the two together at the end?
Sure. All right. Yeah, so how's that going to work?
Wait, isn't this kind of in reverse? Ish. Like, isn't the prefix, isn't technically the suffix what has the consonant? Because like the prefix or whatever, the word starts with a vowel in Pig Latin. I mean, this is just syntax, like how the code actually works.
I think he's using prefix and suffix for like the original word.
Oh, okay.
Those are just names for like the X.
So this would be leading the stuff after the leading consonants in the original word.
Okay, question.
Yeah.
Oh wait, no, never mind.
Well, oh man, that's hard to interpret.
No, it's just kind of like, then I'm just thinking like we need to terminate it, the loop now, or at least yeah. Like once it hits a vowel, because otherwise it's just gonna put all the consonants together. But like once we hit a vowel, we want to like cut it off, right? Like for smile, like once it hits that I, we want to just like stop it and just have SM be the thing you move.
Yeah, so how can I do that?
You do an else statement.
Okay.
Just like stop it. And then I guess it would be like else suffix plus equals. But then I don't really know because we haven't like removed anything from X. You can't just say plus equals X, but we don't want it to go through the rest of C. So it's kind of, I don't know.
Yeah, so, okay, so, or sorry, yes, Isha.
I was just saying like maybe you want to use like a substring from whatever index you left off on, but we're not using indices in this for loop, so maybe not.
We could.
Yeah.
Did anyone have an idea about how we could do that?
Like, could we turn the word into a list?
Sure. How could we do that?
But you don't even have to do that if you use like substrings.
Yeah, there are a few ways to do this. So how are you thinking of setting it up?
I forget the exact syntax with for loops when you're going through indices, but is it like you have to set the length, which we can get from just like the length of X?
Sure, we could do that. So we could do for I in range length
Got it,
of
yeah.
X. Sure, we could do that. And then C is like X of I, something like that. Okay. There's a shortcut for this. We could do IC in enumerate. Has anyone seen the enumerate operator before? So this is a neat thing. Let me do a little demo here. Oops. so it prints out like both the index and the value for each element and anything, it's called any iteratable. So anything that you can iterate through. And that's sometimes really convenient because now we can refer to both the position of each character and which is I, and then the character itself.
What does the F do?
Yeah, so F is it formats a string. So anything that you put into curly braces, like any valid Python expression can go in the curly braces, and then what that expression evaluates to will be turned into a string. And in order to make that happen, you need to use this F at the beginning. So what this does is it says like whatever the value of I is, turn it into so it's saying like string. So we could have done it as like string of I plus colon space plus C, and that would give us the same thing.
Okay.
Yeah, Nathan.
I'm still like a little confused, but because like I was wondering up above, like, don't you for like adding like C to the end, like don't you then need to like delete C from the beginning?
Well, the way I was thinking about it was like, if you put everything before the first vowel in prefix and then you put everything else in suffix, then at the end you can just print out suffix plus A plus, or whatever version, wherever you put the A in Pick Latin. You can just do like suffix plus the prefix plus whatever you need to add on the end. And that'll just be your final result. Like, so you don't actually have to like change the X string. You just have to like.
Yeah.
So like cancels out or something, or.
No, like you don't need to change what's actually in it, because all you have to do for this translator is print out the final thing, which is just a concatenation of the suffix, the prefix, and the ending. So you can just take those three stored things and print that out instead of actually changing what's in the X variable.
Okay, I think that makes sense. Thanks.
I'm sort of confused how we're going to keep the suffix together. Because like if we're just going through each letter in X, then like if the example is smile, then like it'll take the SM and that goes in prefix, and then take the I and put it in suffix. But like, wouldn't L then go in the prefix based on us just doing it by consonant? So we have to like write something so it will take the whole rest of it.
Yeah, so how do we do that? So something weird is going to happen here, or something different, not weird, something different is going to happen here. So by the time we get here, now we're building up our prefix, like the leading consonants. And when we get here, now we've encountered a vowel. And so there are several possibilities. One is that prefix is still empty. And another is that, so if prefix is empty, that means that the starting letter is a vowel. And then we could choose to have like, if it starts with a vowel, then add yay instead of A. Or we could just add A to everything, like AY to everything. So it's up to us. But by the time we get here, now we know that we no longer have to build up the prefix anymore, right?
Yeah, do we want like a return statement or something? Like,
yeah.
Because we basically want to get out of the loop because we don't want it to go through again for the next one. So yeah.
Yeah, so what do I return? We could break also.
But don't we want, because like we also need because right now the suffix is still empty.
Mm-hmm.
Yeah, so that's what I was thinking, like, if you just want to, because we have like the indices now. So if you just want to take everything from like the index that we left off on to the end of the string and make that a substring and put it into suffix, then you would have what you need. And then you can just break from there.
Okay. And now I'm outside of the loop, and then now I have to return something. So
wouldn't it just be like suffix plus prefix plus ending?
Yeah. Great. So let's see if this works.
Okay, that makes sense.
Okay. Oops. Okay. So now let's test it. So what should that return?
Hello, hey.
Great. And what about smile? Oh, sorry, I ran it too fast. That looks right. Of course, okay, so then there are some things to like think about here. So we defined consonants, but we didn't ever use vowels, so we probably don't need to define those. And then, so like this isn't gonna work, right? So how could we deal with that?
Well, there's a Python function like to lower, or is lower. I've definitely used it before. I don't remember.
Yeah, so this will convert it to lowercase. Yeah, so now that'll work. Of course, it'll be a little weird, but so we could maybe say, add the lowercase version. And then what about something like this? Yeah, so that's not going to work anymore. Or what if it's just like smile even? That's kind of weird, right?
So if we wanted to like create a translator for a whole sentence, that could maybe be a different function that uses this just one word function.
Mm-hmm. Okay, so we could say this, let's say this only works for characters, and we're going to ignore, I mean, we could even just say like, let's just return the whole thing in uppercase so that like, it's like we don't have to worry about capitalization. It just will make our lives easier. Oops. Okay. Okay, but we can still clean this up a little bit. So we don't use vowels here, so we could probably get rid of this line.
Wait, couldn't we also alternatively have like if C not in vowels, because vowels is like an easier list to create than consonants, because like you could potentially skip a consonant without realizing it, but vowels is like there's 5 of them.
Yeah, yep, we could do that. Or we could just say if C dot lower in vowels, and then else. Well, oops.
This works too for like if it starts with a vowel, right?
Oops. Yeah, this will work if it starts with a vowel. There's still one more like, okay. So here, I think Amelia, you had the intuition that we could have a return statement. So what we're doing now is like we're looping through. If we get to a vowel, then we break out of the loop and then return. But like it'd be more efficient if we just returned right here. They're going to be functionally equivalent. So we could actually just, does that make sense? So we could actually just call this right here, and then suffix is just x from I to the end. And then
we don't have prefix yet.
Well, we might not. So, well, if you get to this if statement very first, prefix is empty. So you're adding an empty string. But this won't work. So this will work for like smile, but it will not work for something like just the letter A. Oh, just kidding. Oh, it won't, if I guess it's not a valid word. It won't work for like just the letter B. And I don't know is that the correct translation of A? I don't know. Let's say it is. Why not? It's like the word plus AY, I guess. Why not? But this returns none. So for some reason, this isn't returning anything. So we have to add, does anyone see why? What's going on here? So like if you go through the loop and you never encounter the condition where a character is a vowel, then this loop will just go through all the letters. Prefix will be, incremented however it is, but then there's no first vowel. So then we have to figure out like, what do you return in that case? Do you just return the original string? Does that make sense? Oops, just kidding. So like, if you don't have any vowels, prefix is just going to contain the whole string by the time this for loop exits or finishes. But then we haven't returned anything because there's no return statement here. So when you don't have a return statement, it's equivalent to return none. So is that what we want, or do we want something else? What do you think?
Is there ever going to be a situation where it's only consonants, like, and we're translating it? I guess it depends on like if we're just putting like only like real words or if we're going to put random stuff in.
I guess it's possible not. It'd be nice to have like, well-behaved outputs no matter what we put in for input. We could say like, we could have it throw an error like exception. Okay. Something like that. Can you not do quotes in? Huh. Oh, right. Yeah, so this would be the way to. Okay. Okay, great. So that gets us one word. And now what if I want to translate, this is a test. can I make that work? What do you think?
I don't know if you want to write a new function or not, but you could do one that like splits anything based on spaces and then just calls ing to pig on like every word.
Mm-hmm. Yeah, so how could I do that?
I think it would be like you input the string and then I think it's like dot split. It's been a while, but I think it's called split.
Yeah, you're right. Yeah, so if it's a function that's attached to strings in Python, x.split will look for every example of a space and then use that as like the delimiter, and then divide out, okay, this has a space next to it, so this is the first word, is surrounded by spaces, and so that's the second element of this list, a test. And then if you have trailing spaces, oops, wow, that's not what I meant to do. They get ignored. No, they don't. Ooh. Haha, they don't get ignored. I thought they did. I guess empty strings have spaces on either side. So you could do, oops. What's it called? Let's see. Python remove trailing spaces. What's it called? Oh, strip. Gosh. There we go. Yeah. Okay. Okay. So that'll get you a list of the words, and then we could, has anyone learned list comprehensions? Do you remember those? No. We could do like into pig of W for W in this. And then we could join it back by saying space dot join of this. So a string dot join of a list. Oh, okay. I was wondering if that would work. It has to be a list of strings. We'll take each element and put the original string next to it before attaching the next element. So it's also really like convenient if you like want a comma separated list. It can be useful. Okay, and then you can, they can be of any length. Okay, so this takes, so here, has anyone used list comprehensions before? No. Okay, this is useful. So what we're doing here is we're creating a new Python list whose elements are given by well, here, let me break it down actually. Okay. So this quantity here, let's just call it y. Y is going to be a list whose elements are this, is, a, and test, and all strings. Python has this neat syntax for creating a new list out of any, it's called an iterable, so anything you can iterate through. And the syntax is it's kind of like a squished version of a for loop. So you say for each element in the list, we're gonna do something with it. So this is just gonna say, this is just gonna return the original list. But for each word W and Y, make a new list whose elements are given by the corresponding statement here, which is just W. So it's like for the first element, it's some function applied to W, which is the first element of Y. And we're going to make a new list whose first element is that. So, okay. But we could say like W.upper. Now we're going to get the uppercase version of each element of Y. Or we could say like, reversed, etc. Does that make sense? And then list comprehensions can be, weird. So you could say like if, you can like have if statements. So like, oh, whoops. So this will remove anything whose, this is like a way of filtering out some elements. So it like won't run if, it'll only run if this statement is true. So it's only running if each word starts with a consonant. Okay. Anyways, it's a powerful way of making lists. I can maybe link to a tutorial. I'll add a link to a tutorial on list comprehensions if you want to learn more about it. They're not critical for this course, but sometimes they can be convenient. Okay, I'll add that to module 3. Okay. So what this is doing here is it's applying this ing. So ing to pig is a function we wrote that just applies to one word at a time. And what we're doing is we're taking X, stripping off any leading or trailing white space, splitting it by spaces, and then we are, so this is a list of words whose, well, this is the list of words that we passed in X. For each word W, we're making a new list whose elements are W translated into Pig Latin. So this is going to be a new list. And then we can join it to, does that make sense so far? All right, what's confusing here? Is it too much to throw at you in one? Maybe.
I'm a little lost, but I'm
You're
not sure what
lost.
other people are.
Can you like, yeah, no, it's good to identify. Can you like, should we do this as a
Like
for
say
loop
why?
instead? Or? Yeah, or like, can you put your finger on what isn't making sense here, or like?
I mean, I understand like that is like separating. Well, first it's like separating, it seems like the different words. And then since it has like that engines or not that English to pig function, like that's like referring it back to our function above and like going through the whole like translation for each of them. Is that basically it?
Yeah, so we could do like we could do something like this. We could also just call like, so
you know, this just runs whatever function we pass in to like on each element in turn of this list. So we could print out each element, and then the print function returns none. So the list that we get out at the end is just one value of none for each element of the original list.
Wait, what? Why does it do none, none, none? Sorry.
So print of anything, it prints out that thing, but it doesn't return anything. And by default, when a function doesn't return something in Python, its return value is none. And so this statement evaluates to true. Like, in other words, the value of the thing, of this function, when you evaluate it, is none. And so, like,
oh, okay. I think I see what you're saying.
Okay, yeah.
And like one more thing too, like, can you just like, why again did we change it to like, instead of like having the consonants above in the function to like the vowel to like C dot lower in vowels? Is that just like, because like both of them work?
Yeah, both of them work. It's just easier to type out the vowels, right? Because it's,
Okay.
you know, a shorter string, and we were only using one of them.
Okay, that makes sense.
Why is it that like when you called Y or whatever in like 90 that it showed the none, 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 none? Like, is that a Google Colab thing that it just like puts the return value in that lower box?
So if you evaluate the statement by pressing Shift Enter here, it'll print out the values of that variable. So if,
okay,
that's right. Yeah. So this is like the thing that's printed below each cell is like anything that would be printed to like the Python terminal or Python console. And then like, since Y is a variable we defined in the previous cell, or actually it's just anything we've defined up into that point. So, you know, these things don't even have to be executed in order as we're working on it, which is strange.
so like for 88, when it's like print test is none, it prints the test because that's in the parentheses, but then it also prints true because that's the return value.
Exactly.
Okay.
Yeah.
So I was a little confused because I haven't used it like this before.
Yeah. So if we did this, it would just print
okay
test, and then return val is none. Oh, I'm sorry.
It's true.
It's true. Sorry.
Yeah. Okay. No, but that makes sense. Thank you.
But now it would be none. There we go. Oh, it doesn't print none by default. Let's see if this works. There we go.
So wait, why did it print the none, 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 none by default in 91? Like, why is that different?
So it looks like it suppresses print statements if the value is none, but a list of nones is not none. So
okay,
this would be false, weirdly.
okay.
Yeah. So we could have a list of 4 nones, and that will be 4. Yeah. Even though there's nothing in the list. Yeah. Or the thing that's in the list is Python non-objects. It's like having 4 null sets. Okay. Cool. Do you remember recursion at all? Is that evil?
I never understood recursion.
All right. That's a good place to end then. So let's do this. So yeah, recursion is like defining something with itself. Okay. So let's say well, first let's strip out any white spaces.
Okay. And then we could say like, if length x dot split equals 1, actually, if x is the empty string, then let's just return it. So after removing all the white space, if x is the empty string, just return it. Otherwise, if there's just one word, so let's see what this does. So if I say like hello dot split of space, it's just going to return a list of that thing because there's nothing with like spaces in between it. So if we're in this case, then we can return all this. And then otherwise, length of x dot split of space is greater than 1, then we could return, well, first we could say like translated words equals into pig of w for w in. So we could like split these, right? And then we could return those things joined together again. Does that make sense? Okay. Or to be fancy, we could just make this all one line. They don't have to be second, like 2 lines. Okay. Yeah, Nathan.
So for the first part of this, is that basically saying like if there's not a word, return it?
Yeah, so what happens if you just pass in this? It should just give you like an empty string. Or if you pass in like a bunch of spaces, it should just give you the empty string.
And that's like what the first part is doing?
Yeah, so if, after stripping out the white space on the ends, then if there's nothing left, just return the empty string. This also accounts for, if I say like this is a test, it'll give back, oh, I guess it just, right. Well, that's not totally nice. So let's see, how could we fix that? Well, I don't know. It's not very nice. Maybe we could come up with a elegant way of saying like, if there's multiple white spaces, maybe we just want one white space. The reason this doesn't work is, so if I say, this is a test dot split of space, I get those empty spaces in there. And so what's happening is when these empty strings are passed into pig, it's returning an empty string again. And then those are getting rejoined.
So I guess I have a question, like what would happen if you didn't have that first part?
This part?
Yeah, like what would happen, I guess, yeah, if you didn't have like that whole section, like the return x, the x dot strip to the return x.
Yeah, let's see. So that works. But what if you have something like this? Yeah, just gonna give you nothing. or I guess it raises an exception because it's saying there's an empty string. So that this is raising this exception. So, well, let's walk through it. When you say this empty string dot split of space, that's going to give you a list of an empty string. So the length of that list is 1. So this condition holds. And then we do our regular translation, but there are no vowels here. And so this for loop is going to exit without us having returned anything. And when that happens, we raise this exception.
So is that like what we want?
Well, we get to pick. I think.
Or would you?
I think it's more elegant to have it return an empty string.
Okay.
But we don't have to.
Okay. I think, yeah, I understand now. Like what I guess like the purpose of that is.
And this line here just removes leading and trailing white spaces, so it's not critical, but it makes it a little prettier. Okay. Okay. So since how was that? Was that useful? Okay. So so I have two. So since you all have, like, I've never actually taught this course where everyone had some programming experience before, so I'm in new territory here. So one idea I had, so we kind of have two options, and I'd be interested in your feedback. So one option is we could like keep going, play around with a few more demos, so I could make up some other examples. We could go through them as a class. And then we can either work on them as a full class or in breakout rooms, whatever you're feeling at the time. And then another option is to just like move forward with module 4, like, because module 3 is really about getting you up to speed with Python. So we could like take another day, if that, to go through, make sure everyone's set up with GitHub and Collaboratory and all that. But once we do that, we can move on to module 4 and just get to the rest of the course faster. So yeah, what would you like? Yeah.
I don't know about other people, but I think if we could do a little bit of time like talking about GitHub and just how it's going to work with like submitting assignments and stuff, because I watched the videos and like I understood them from like a you explaining it level, but I don't know if I could like do it for myself right now. So that would, at least like for me to take a few minutes, that would be helpful.
Sure. So Nathan, did you have something else to add?
Yeah, I just like agree. Like I think it'd be helpful to get like used to this stuff a little bit more. I also like was wondering too, like what would we be using like Python for specifically?
Yeah, so you're going to use Python. Well, so for assignment 3, you're going to use Python to write like a converter that goes from base 10 notation to binary, like converts numbers to binary. So that's like a quick example. But then as we move on, so that's, the point of this assignment, that assignment is to like, make sure you have some kind of basic Python proficiency, but it's probably less difficult than the English to Pig Latin translator to implement. But then moving on in the course, you'll be using Python to analyze data and make graphs and stuff like that. But we haven't learned how to make graphs in Python. So module 4 is about like the data science toolbox for Python. So there are lots of libraries that are specifically used to like make visualizations and analyze data that we'll cover in module 4.
Okay, gotcha.
Okay, well, here's one idea. On Wednesday, we could go over, if you want to come to class with questions about GitHub, we could, go over that. I can kind of leave the time unstructured. And then if you want, we can go through like another demo like this, like an example, some other quick problem to go through. Or we could go right, what, I don't know. Well, maybe so that's one option. Do you want to do, how does that sound? Would that be helpful? Okay. I could since you have some exposure to Python, I could like bring in some concepts that I don't typically teach. Like there are other interesting Python things like decorators, and I could go more into list comprehensions to unpack that a little more. Or not.
Yeah.
What would you like? Okay. All right. I'll maybe think of some like interesting Python things, and maybe we could do a little demo. So we'll prioritize answering GitHub questions, and then in the time remaining, we'll learn about some of the more like sophisticated Python things, and then do a little demo. All right. Cool. Okay. We'll see you on Wednesday. Bye, everyone.